Okay, the next challenge is how do we create a container of pets? Okay, cat and dog are two different classes, right? So two different classes, unfortunately, cannot be saved or populated within the same container. Standard library, say if this was for instance, a vector, right? If we're moving in the direction of using vector as our base container, we cannot really create a container of cat and dog at the same time. It's not possible, right? There is no such thing as container of heterogeneous types. We call all containers within standard library in most programming languages as homogeneous containers, which are expecting the same type of object. And of course, if I want to use a vector, I need to go up and somewhere say that I do want to use a vector. Right? Vector is a first choice type of sequence container that is highly recommended for using. And of course, its full name is std::vector, right? But because I'm saying, well, don't worry about it, I'm using this namespace here. Anytime you are curious about what that name is, just assume that it's coming from the standard library namespace, and so I can just say container. So, but back to the original problem that you cannot have like for instance, having a container of cats is fine. Having a container of dogs is also fine, but not both. Or, just, it has to be the same type. Okay, so switching over here, the trick is that we need now a container, right? So we can say, we call it pets, right? We need this container, which I will draw like this, like potentially a big list of different types of pets, which I would like to populate with simply, instances of the pets that I would like to create. So I can be pushing back, and adding them. And the trick really is the solution to this challenge that it cannot include both cats and dogs because they can be potentially different size and memory. The solution, of course, is through indirection, and indirection means that the container of pets has to be populated by pointers. But pointer to who? Not to a cat or a dog, but rather to the pet inside that we know that each of these, each instance of cat or dog or horse or anything else that you want to add actually will include the pet component, and therefore that pet component does exist in memory, and therefore it should be possible then to say, how about this? We create container of pointers to the pet object. Okay, so that should be quite doable. All right. Then of course, if I want to populate this vector of a vector of pointers to pets with the cat and a dog, I can simply say, what's your address, right? Just say, what's your address? This is how we extract information about the object in memory. Basically, use ampersand to say, what is your address? Like, ask that instance of cat, what's your address? And then ask the dog, what is your address? Okay, and then of course there is this challenge for the print, right? So now we're as far as container can be created and populated with addresses of these objects. Okay, this pets container is now a vector of pointers to pets, and pets are now included in both dog and cat. And guess what? If you take the address, the vector will be happy to take that address and essentially will say, yeah, I understand what you mean. I do find a pet inside each one of these objects, and so I can accept that. So how do we print? Well, first of all, we don't even have a print function. So ultimately, we want to basically say that cat, this is, let me just resize this a little bit to fit everything on one screen. Right. I wish my screen was wider, but our projector permits only this size, so this resolution. So I'm limited here. So this is what I'm going to say. Apparently, some sort of void print function takes no parameters, most likely doesn't modify anything inside my object, and all that it does is basically says std cout, right? Standard output, say meow, right? For the cat. My name is, right, and it can print. Let me just type this like this, more standard way. And my name is, and space, and print what the name is, right, just like this. Print the name, and for simplicity of output, I will be using, I will be also adding a new line at the end so that we don't have problem with formatting any of this, right? So print, this print will be specific for a cat, right? And then another version for a dog will be just basically, instead of saying meow, say bark, right? My name is such and such. But you know that the default type of access to members inside our classes is private, right? We don't have to say private, but this name is private, and what it means that despite the fact that the name here, let me highlight this for you. This name is included in both cat and dog. However, the only part of the code that has access to this is inside the pet, because private is the level of access, and therefore, this constructor can access name without a problem. But even if you derive a cat from pet or dog, they cannot have access to this. Sometimes it's just pure inconvenience, so the right way of handling it is to say, well, you know what, maybe we do want to keep the name private, except that whenever anyone derives a new class from the class pet, let them have access to it, and it is called protected, right? So protected means that outside of the class, the name cannot be accessed. However, oops, right? So this name is private with all respects, except that in derived classes, this name can still be accessed, because we said we use protected level of access. That's what protected really means, okay? So we now have functions, print, that we gave to both cat and dog, right? And so now if we try building it, everything is almost complete and done, except that it says right here that my error message says print must have class struct union qualification, and it just doesn't happen to be the case. Well, what happens is that, first of all, because I'm saving pointers, the type of pointer access to a member function such as print requires, instead of a dot, requires an arrow, right? So this is member dereference operator. So I can change that, but also recall that what we store inside this container is actually pointer to only a pet. And pet, by the way, does not have a print. So it also needs a print. Right? So right here, it needs to say void print Okay, and this print is also a constant function, something like this. And I don't know what its definition is, because what I would rather want to happen is that instead of calling this print, I want this to be a dynamic dispatch to print here or here, depending what type of object this is. Essentially, right here, right here inside a cat, I have this print function, which essentially print function does something different, right? So this is print that works for the cat is different compared to print that works for a dog, right? And I want to make the distinction. So when I say this is obviously index 0, which is a cat, and this is index 1 inside this container, right? So when I say print, instead of going to the pet version of print, I would like this call to be dispatched to the actual version inside the cat, or the actual version or implementation of this function inside the dog. How can this be done? And the answer is, instead of providing this implementation, we can say that there will be no implementation. We say equals 0. This makes this function print inside a pet what we say abstract or pure virtual function. And also we want to say that anytime this is invoked, we want to dispatch this call to the underlying derived objects. This is done by declaring this function a virtual, right? So we say, okay, we have a print. We want to be able to call print whenever we want with any pet we want. However, instead of using any kind of pet level implementation, we say, no, we don't want any implementation, right? So this, by the way, has a technical designation, and it's called pure virtual function, just like this. And whenever we say pet pointer, which is element 0 or element 1, and we say print, anytime we do something like that, we want to dispatch it to the appropriate function call, and this is what is done through this qualification virtual. By the way, in Java, a virtual is spelled as abstract, right? So in Java, this would look like this. Abstract print, and you don't have any of these parts. This would be a Java version of this pure of the pure virtual function. Obviously, it's not going to work for us because this is not Java, so I'm just going to essentially comment this out, but that would be the syntax inside Java.